All right. Today we are talking about rectangles and squares. You guys know all these rules already. I know you do, but we'll just go over them again. So, properties of rectangles. I've got opposite sides are congruent, obviously. Opposite sides are parallel. Yep. Opposite angles are congruent. Consecutive angles are supplementary. They make 90. All the corners are 90 degrees, guys. All the corners are 90 degrees. Diagonals bisect each other. Okay, I'm going to add two more. All four angles are right angles. Okay. Then diagonals are congruent. Okay. So there is that. Okay. Easy stuff. We're only going to be able to do like every other example because if you notice, like 1 and 2, pretty much the same type of math, but so we'll do like 1, 3, 5. Okay. Number 1. Well, if opposite sides are congruent, that means that this is 10. If the top is 24, the bottom is 24, right? So that's nice. Oh, how am I going to figure out how long the diagonals are? How would I figure out how long like PR or SQ is? What would I do?
The Pythagorean Theorem.
The Pythagorean Theorem. Here's the 10, here's the 24. 10 squared plus 24 squared equals C squared. And, oh, hold on. All right. The only thing I don't have memorized is 24 squared. 576. 100 plus 576 equals C squared. And then I'd have to do the square root of 6. Yay. Well, it would be good if you could actually see the screen. Square root of 676 is 26. Okay. So that's nice, right? Now, I know that PR is 26. SQ is also 26. And then just go through the rest, guys. QR, that's the right-hand side, right here. QR, 10. SR, 24. Ooh, if the whole diagonal is 26, what's QT? Volunteer, you have to write so I know whose voice I'm listening to. Yes, Gabe.
13.
Yep, half. Good job. Easy, right? Okay, let's do number 3. Ooh, 27 degrees. Didn't I say that every angle was a right angle? Right? Angle J has 27 degrees. That's partially done. But what about the 27 that's already taken up? So I'm going to do 90 minus 27. Okay.
$63.
Good, yay. So that means that this is 63. And I have to start using a mechanical pencil because the numbers get so small. Okay, how do I know what the other angles are? How am I going to figure that out? Somebody tell me, what do I do? I only know J. Can I do anything else? Can I figure out the angles of K or L or M? Hi. Hey, welcome to geometry. Nice to see you. What do I do to figure out K or L or M?
You can use opposite angles are congruent for L.
I could. And since the lines are parallel, these are going to match up. 27, 63. It works for all of them because I have parallel lines here. So this is going to be the same, guys. They're all like the same. 63, 27.
Miss Grant, how do you like just determine them whether they can be like parallel lines or not?
Oh, it's part of my property. Opposite sides are parallel. And a rectangle has parallel lines.
Oh, okay. Thank you.
Yeah. So I got all my angles filled in. Now all I have to do is just go through and do the blanks. Measure of angle MJK. MJK, that's the whole thing, MJK. Obviously 90. MJL, MJL, half, not half, I'm sorry, not half. It's marked up as 63 degrees. JLK, JLK, that's marked right here, JLK, 63. KML, 27 degrees. MNL, oh, I don't know. Base angles are 27. It's an isosceles triangle. What's this one? Because don't they all add up to 180 in a triangle?
126.
Oh, you're all right. 126. Very good. Okay. All right. I want you to do number 5 on your own. I'll mark up what's given. DB is 42. Oh, if it's 42 all the way across, that means that it's 21 because they're bisected, right? AD is 26. DAE is 52. And you know that 52 is also then this one, alternate interior angles. All right, anyways, you're supposed to be doing it by yourself. I'm gonna stop. I'm gonna press pause on the video so that the video doesn't like. All right, so let's go. I have volunteers for these. So AC, what is AC?
42.
42, you are correct, thank you. What is EB?
21.
It sure is. What is BC?
26.
Yep. Good. Okay. Next, AB.
33.
Good. Did you get that doing Pythagorean Theorem?
Yeah.
Yep. Oh, 42 squared, not 4 squared. Which is really AB. Good. Okay, the measure of angle ADC, sir.
90 degrees.
Oh, that's an easy one. Good job. The measure of angle ABD.
38 degrees.
38 degrees, yes it is. And then if I got 38, that means that I got BCA as 52 degrees. And then the measure of angle DEC was 104 degrees. Good. Okay.
Miss Grant,
So, yeah.
how did you get AB?
Oh, I did the Pythagorean theorem. It was this. This was 26, and this was 42, and this was unknown. So that's what the triangle looked like, and so that's AB. Okay.
How'd you get ABD?
Oh, because remember how 52 plus what makes 90 degrees? 52 plus 38 makes 90
Okay.
degrees.
Thank you.
Yeah. So I'm going to turn over and go to squares. And squares, you guys, so nice. Every corner is 90 degrees. It's cut into 45 and 45, right? It's a square. The diagonals are equal. Let's turn the page. Properties of squares. Opposites, I mean, I'm not going to read all those. You guys can read all them. Basically, every corner is 90 degrees. It's cut into 45s. The diagonals are the same size. They bisect each other. The lines are parallel. The sides are congruent. Everything else. So here it is. Okay. ABCD is a square and AD equals 11. Okay. All right. So BC is 11. Oh, by the way, you guys, these are 90, but they're cut up into 45, 45s. I mean, we know that, right? 45, 45. The diagonals are perpendicular, so those are 90s in the middle. All right. AC. Woo-hoo. I don't know AC. Pythagorean theorem. 11, 11. 11 squared plus 11 squared equals C squared, right? 121 plus 121 equals C squared. So 242 C squared. And square root both sides. C equals 15.6. Okay, that means that the diagonals are 15.6 long each. If I bisected them, okay, so AC is 15.6, right? BD. BD is a diagonal. It's also 15 and 6/10, if you want to say it properly. 15 and 6/10. EC is half of a diagonal. Half of 15.6.
7.8.
7.8. You are correct. Oh my gosh. Do you guys remember like years ago when that dab, when like people used to dab and that was like a cool thing to do? Isn't it funny how things just like all of a sudden it's not that exciting anymore? But here's dab, measure angle DAB, 90 degrees. AEB. Oh, it's also a central angle, 90 degrees. CBD. Oh, it's 90 cut in half. CBD, right here, 90 cut in half. And BAC, 45. Okay. That's 6. We're going to do the evens. We're going to do 8 and 10. All right. Yesterday we talked about rhombus. So we need to kind of refresh our brains on that. But the sides are congruent on a rhombus. So that means that I'm trying to find MP. All right. Well, all the sides are congruent. So if I find one side, I know all the other sides. But all I know right now is the top. I've got an expression for the top, an expression for the bottom. Since the sides are equal and congruent, I can then say that the top 9x minus 77 is equal to 3x plus 7. So I'm going to subtract 3x. Six x take away 77 equals 7. Six x equals 84. X equals 14. So I found the value of x. X equals 14. And that 14 is going to be what I plug in to find one of the sides. This side seems to be the shortest. 3 times 14 plus 7. Anyways, that's 49. MP is equal to PO, by the way. They're all the same. 49. Because all four sides are congruent. It's literally a square that's just like shifted. So the sides are still the same length. All right, last one is just the square. Okay. STUV is a square with SW 2x plus 13. I need my mechanical pencil. And WU 8x minus 41. Okay. They are equal because diagonals are bisected. So I'm going to set them equal to each other. 2x plus 13 equals 8x minus 41. And then you just subtract. Six 13 equals 6x minus 41. I hope these, solving a two-step equation is super easy for you. We would be in a world of hurt if you guys were having trouble solving two-step equations in algebra 2, right? Or in geometry. Sorry, I teach algebra 2, and so it's like, am I in algebra 2 or am I in geometry? Anyhow, x equals 9. What's the question asking? VT. The diagonals are the same size. SU is the same as VT, but I don't know how long SU is. I only know x is 9. So I need to maybe find one of the sides and double it, like one of the halves, like this is half of the diagonal. 2 times 9 plus 13. 18 plus 13. So it's 31. So that means like half of it is 31. SW equals 31. That means the whole thing, SU, is double 31 because the diagonal was cut in half, and so I'm going to double it, 62. So then if SU is 62, then I can assume that the other diagonal is VT equals 62. Diagonals are congruent. Good. Okay. Let me stop the recording.